Even though humans have wondered about the moon for as long as they've walked on Earth, we are still learning new things about it. Indigenous peoples around the world had specific names for each phase of the lunar cycle, which helped share knowledge about the natural environment across generations. In North America, colonists used the names they learned from Native Americans and applied them to the Gregorian calendar. Even Shakespeare displayed some lunar science knowledge, writing, "Do not swear by the moon, for she changes constantly," in Romeo and Juliet. It turns out that Shakespeare was more right than he knew. Our understanding of the moon is changing constantly, including answers to questions as basic as where the moon came from. It may seem strange, but scientists have struggled to come up with a satisfactory explanation for the moon's origin. Just this year, researchers have developed a new potential explanation of how our closest neighbor came to be. Since the 1970s, when Apollo astronauts returned to Earth with almost 900 pounds of lunar samples, the long-standing theory was that a large planetary body, sometimes called Theia, around the size of Mars collided with Earth, knocking dust and rock off the intruding body into orbit. According to this giant impact hypothesis, the loose dust and debris eventually formed of the moon, but there are a few problems with that theory. In short, the moon's chemical composition looks a lot like the Earth's. If the Theia hypothesis were correct, the moon's chemistry should be more different from Earth's. Additionally, previous computer models suggested that in order to form a lunar body, the impact hypothesis would also have required a large body with a very specific size, velocity, and angular momentum to graze the Earth, sort of a perfect storm of planetary collisions, that is highly unlikely. But according to a new modeling study published in the Journal of Geophysical Research Planets, there are many potential impact scenarios that could have formed the moon. The authors suggest that the moon actually formed inside a giant, donut-shaped cloud of molten rock, known as a synestia. Synesties form when a giant impact puts enough energy into a planet to partially vaporize it and increase its rotation speed. When a planet spins that fast, its outer cloud of rock vapor needs to rotate much faster than the core of the planet, known as the co-rotation limit. Synesties are planetary bodies that are above the co-rotation limit, which had never been studied before.